Good morning. Today we are correcting CO23. We're talking about those greatest common factors. So we did the first page we did together, learning about prime factorization, listing, and tables. Then you got on the second page to choose which one you wanted to do. So it doesn't matter which method you use, we would get the same answer. So no matter what method, I did the prime factorization just because that's what works well for me. If you're not sure how I got the greatest common factor that I got, we can work through whatever method you used so you can see where your mistake happened and learn from it. So our first one is greatest common factors 9, 6, and 12. In the second row, it's 16, 6, and 5. Is there any that anybody wants me to work through so you can see where you went wrong? So we're all getting the same greatest common factors. Adeline? 48 and 32. What method did you use, Adeline? The listing. So for 48, listing all of those factors, we would have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. I think that's it. Did you get all of those for the 48? Okay, then for 32, we would have 1 and 32, 2 and 16, no 3, 4 and 8, no 5, no 6. I think it's just those ones. Is that what you got for 32?
Yeah, I put 8.
You didn't put the 8?
I put the 8 as the answer.
Oh, did you have 2 and 16 listed? Okay, so that, remember I said that can be one of the tricky parts when you're doing the listing method. You might forget a factor pair, and it could be the one that has that greatest common factor. So we have to be really careful when we're doing the listing that you go through. What I do is I always start with the 1, 2, 3, 4, 5, 6, 8, and 9, those and 10, those divisibility rules that we did. And that's what I was doing in my head. I was going through all those divisibility rules to make sure that I got all of the factor pairs, because it's really easy to miss one. Any other one that anybody wants me to go through so you can see where your mistake happened? It's how we learn, learning from our mistakes. Who's going to be brave? James?
The table on 18, 30, 42.
All right, if we do the table method for 18, 30, and 42. What is the first number that you pulled out, James?
2.
Okay, so 18 divided by 2 is 9, 30 divided by 2 is 15, 42 divided by 2 is 21. Is there another number that we could divide out of 9, 15, and 21? There is. 9 can be divided by 3. 1 plus 5 is 6, can be divided by 3. 21 is 2 plus 1 is 3, can be divided by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. 21 divided by 3 is 7. So we had 2 numbers over here, so we do 2 times 3, and that's how we get 6 for our answer.
I should have just looked at my paper because I did it like that.
Okay. Any other ones we're not sure on? All right. Let's look at the bottom part. So you're given a word problem that includes the phrases identical and all of the items. You'll be using greatest common factor. Those are key terms to look for. If you see that they are identical groups, and that they all have this, all items are present in all of them, you know you're finding that greatest common factor. So Mr. Schultz is making lunches for his children. He has 8 sandwiches, 20 beef jerkies, 12 strawberries, and 44 gushers. How many identical lunches can he make using all of the items? So we need to find that greatest common factor of all 4 of those numbers. I used the prime factorization, and they all shared 2 2s. 2 times 2 is 4. So he would be making 4 identical lunches. Any questions on that one? Adeline,
I got A.
what method did you use?
I yes.
You listed? Okay, so if we were going to list for these, we would have 8, 20, 12, and 44. So 8 would be 1 and 8, 2 and 4. 20 is 1 and 20, 2 and 10, 4 and 5. 12 is 1 and 12, 2, 6, 3, 4. And 40 is 1 and 40, 2 and 20, 4 and 10, 5 and 8. So we know we've got the 1s, 2s, not 3s. We've got the 4s. When we look at those 8s, 20 and 12 don't have 8s. So we can't use that because all 4 numbers have to have the same factor. So the biggest number that we have, because 8 only goes up to 8, the biggest one that we shared was the 4s. Does that make sense? All right, and just for funsies, how many of each item will be in each lunch? Well, if there are 4 lunches, we're going to find its factor buddy for each item. So for the sandwiches, there are 8. So that would be 4 times 2. So if there's 4 lunches, there'll be 2 sandwiches in each lunch. Oh my goodness, these kids eat a lot. Beef jerkies, there are 20. So if there are 4 lunches, its factor buddy is 5. Strawberries, there are 12. The factor buddy of 4 would be 3. And for gushers, there are 44. The factor buddy of 4 would be 11. So if we know there's 4 lunches, you put its factor buddy. What number goes in the pair with it to multiply together to get the total amount? Does that make sense how I found those? So there would be 2 sandwiches, 5 beef jerkies, 3 strawberries, and 11 gushers. Any questions? All right, time for review. What is the divisibility rule for 3? The sum of the digits is divisible by 3. You add up the digits, and if you can divide that number by 3, then it's divisible by 3. Divisibility rule for 5, it ends in a 5 or a 0. For 6, it needs to be divisible by both 2 and 3. Is 45 a prime or composite? It's composite. It's divisible by 5 and 9 and 3 and 15. It's divisible by lots of numbers. Yes? And honestly, it just asked, is it prime or composite? You only had to put prime or composite. I went above and put why it's composite, but you only had to put prime or composite. 51 is composite. It's divisible by that 3. 29 is a prime. What is the prime factorization for 42? Break it down to its primes. It's 2 times 3 times 7. And for 60, it's 2 times 2 times 3 times 5. Adeline. And 21 isn't a prime. We can break down that 21 into 3 times 7. Remember, you always want to see, can I break it down into other numbers that multiply together to make it? So you want it to be just that, down to the prime numbers where it's itself in 1. Nothing else can multiply to it. So the 21 you had to break down farther. Any other questions? All right, if you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.